Hi, ladies and gentlemen. I wanted to walk you through the OWL 7.2 Science Notebook Option Z if you needed a little help. So first of all, how do you get to Option Z? You're going to go to Google Classroom. Okay, you're going to, I'm right now going to third period, but you could go to any of your, whichever class period you're in. Go to your classwork. Okay, scroll down to the atoms and molecules heading, or you can click on atoms and molecules here off to the side. Okay, and you'll see the assignments listed for you. Okay, and I am looking for my OWL 7.2 Science Notebook. And then you guys are going to look for option Z. Okay, so hover over the top so you can see the names. Yours, I think, are listed off to the side here rather than in the middle like mine is. In any case, find option Z. You're going to click on that, open it up. Hopefully you have Adobe Acrobat for Google Drive. If you don't, I can help you get that. So just send me a message and I can give you a little tutorial on how to get it. Okay, so send me a chat message and I'll help you with that. Okay, if you're working in Adobe Acrobat, okay, as you're working, you're going to see a save button pop up here on the top. So you want to save as you go along today. Okay, so protons, neutrons, and electrons, how atoms differ. Okay, so you guys are going to start off. What do you think? Okay, there are three statements. We need to say if you agree or disagree before these three statements. Okay, so you're just going to put an A or a D in each of these boxes. So I click on the box and I decide agree or maybe I disagree. Okay, so put whatever letter you think in that box ahead of the statement. Okay, the first statement is all atoms of the same element have the same number of protons. Okay, so maybe at this point you know the answer to that. If you don't, right, you're just going with agree and disagree, and hopefully by the end, okay, your statement, you will know for sure whether or not that's true. Okay, on the second statement, atoms of one element cannot be changed into atoms of another element. Okay, so again, you put agree or disagree. Okay, and then the third statement, ions form when atoms lose or gain electrons. Okay, so you should have an A or a D before each of those three statements. Okay, so we're going to go through and read together each of these sections. So as we're reading, okay, there are some things that we're going to try to do. So it says building vocabulary. As you read, circle all the words you don't understand. Highlight the part of the text that helps you understand these words. Okay, so up here at the top are some tools for you to use. There's a highlight tool, and then there's a pencil tool. So that's what you can use for highlighting and for circling. Okay, review the words, the marked words, and their definitions after you've finished reading the lesson. Okay, so in science, there is a lot of terminology in science. So a lot of words that aren't used in everyday language, right? So we've got to become familiar with them. So the more you can kind of practice using them, that's why I give you guys the vocabulary Quizlets. Okay, the more help you will have in terms of getting familiar with those terms. All right, so let's get started. The parts of the atom. Inside an atom is a very tiny nucleus surrounded by empty space. Positively charged protons and neutral neutrons are inside the nucleus. Negatively charged electrons whiz by in the empty space around the nucleus. The table below compares the properties of protons, neutrons, and electrons. Protons and neutrons have about the same mass. Electrons have a much smaller mass than protons or neutrons. As a result, the nucleus contains most of the atom's mass. All atoms contain protons, neutrons, and electrons. However, different types of atoms have different numbers of these particles. All right, ladies and gentlemen, there's a table below that essentially summarizes everything that was set up here. Okay, so we've got this table about protons, neutrons, and electrons. We see symbol, charge, location, and relative mass. Okay, and then each of the subatomic particles is listed, electron, proton, and neutron. So you'll see the symbol for an electron is E with a negative sign. Protons are P, usually it's P followed by a plus sign. And then neutrons are N, and they're all lowercase letters. The charge on an electron is a -1 charge or a 1- charge. Protons are +1 or 1 followed by a plus sign. And neutrons are neutral, so they have no charge, so there is a 0 there. The location of the electrons. Electrons are found in the electric cloud around the nucleus. Protons are in the nucleus, and neutrons are also in the nucleus. And then the mass of an electron is 1 divided by 1,840. So this is a very tiny number. So it's 0.00000 some stuff. Okay, that means that the mass of an electron is essentially 0. The mass of a proton is 1 atomic mass unit. The mass of a neutron is 1 atomic mass unit. So the mass associated with an atom is related to protons and neutrons. Electrons essentially don't count. So we should be able to answer our first question here. What does the negative sign in the electron symbol mean? Okay, so we see E minus. Well, what does that minus mean? That has to do with the charge of the electron. That has to do with the fact that electrons have a -1 charge. So you should be able to answer question number 1. Okay, then we're moving on to different elements, different numbers of protons. Okay, so it says, look at the periodic table on the inside back cover of this book. Okay, you guys don't have the book, but you guys saw the periodic table on our lab this week. Okay, notice there are more than 115 different elements that have been identified. Recall that an element is a substance made from atoms that all have the same number of protons. For example, the element carbon is made from atoms that all have 6 protons. Likewise, all atoms that have 6 protons are carbon atoms. The number of protons in an atom of an element is the element's atomic number. The atomic number is the whole number listed with each element on the periodic table. Okay, so it says identify. What 2 numbers can be used to identify an element? Okay, so when we are looking at that paragraph, okay, and then down below, it says what makes an atom of one element different from the atom of another element? Atoms of different elements contain different numbers of neutrons. Okay, the number of atoms of different elements contain different numbers of protons. The number of protons is the element's atomic number. Therefore, different elements have different atomic numbers. Okay, so what can be used to identify an element? You can either identify it by the number of protons or by the element's atomic number. Okay, for example, oxygen has 8 protons. Its atomic number is 8. If an atom has 7 protons, it is a nitrogen atom, and its atomic number is 7. Okay, explain the difference between an oxygen atom and a carbon atom. Okay, so up here in the first paragraph, it's talking about carbon. Okay, the element carbon is made from atoms that all have 6 protons. All atoms that have 6 protons are carbon atoms. Okay, so then we need to find out a little bit about oxygen. Okay, so that's where in the second paragraph it talks about oxygen. Oxygen, an atom of oxygen has 8 protons. Its atomic number is 8. Okay, so you should be able to compare oxygen down here in the second paragraph and the number of protons it has and its atomic number to carbon, the number of protons carbon has, and carbon's atomic number that's up here in paragraph 1. So that should help you answer question number 3. Okay, then we're moving along to talk about neutral atoms. Okay, neutral atoms of different elements also have different numbers of electrons. In a neutral atom, the number of electrons equals the number of protons. Okay, so that's super important. Neutral atoms, the number of electrons equals the number of protons. Thus, the number of positive charges equals the number of negative charges. Okay, protons are positively charged, electrons are negatively charged. So if the number of electrons and protons is equal, those charges will be equal. Okay, the figure below illustrates 3 neutral atoms. Each has the same number of electrons and protons. So here's carbon, It has 6 protons, 6 electrons in the electron cloud. Okay, nitrogen, and you can't see the electrons because they're so tiny, right? They're just somewhere floating around in this cloud. Nitrogen has 7 protons and 7 electrons in the electron cloud. Oxygen has 8 protons in the nucleus and 8 electrons out somewhere in the electron cloud. So that is those are 3 different elements, 3 different numbers of protons, okay? And the number of protons and electrons are equal because these are neutral atoms. Neutrons and isotopes. Okay, neutrons and isotopes. You have read that the atoms of the same element have the same number of protons. However, atoms of the same element can have different numbers of neutrons. For example, all carbon atoms have 6 protons. Okay, so no matter what, carbon, 6 protons. However, some carbon atoms have 6 neutrons, but some have 7, and some have 8 neutrons. These 3 different types of carbon atoms are shown in the table below, and they're called isotopes. Iso means same. Isotopes are atoms of the same element that have different numbers of neutrons. Most elements have several isotopes. Okay, so here are 3 different isotopes, carbon-12, 13, and 14. Okay, you'll see that carbon-12 has 6 protons, carbon-13 has 6, carbon-14 has 6. Okay, what do the 12, 13, and 14 have to do with? That has to do with the mass number. So carbon-12 has a mass number of 12. Carbon-13 has a mass number of 13. Carbon-14 has a mass number of 14. Okay, so that means in order to get different mass numbers for the same element, they have to have different numbers of neutrons. Okay, so why do the isotopes of carbon have different mass numbers? They have different mass numbers because the number of neutrons in these carbon atoms is different. All right, protons, neutrons, and mass number. Mass number of an atom is the sum of the number of protons and neutrons in the atom. So here's the equation, mass number equals protons plus neutrons. Okay, this is also called atomic mass or atomic weight. Okay, they are used interchangeably. Okay, so it's number of protons plus neutrons. Okay, you can determine any one of these 3 quantities. So you can determine the mass number or the protons or the neutrons if you know the value of the other 2. For example, to determine the mass number of an atom, you must know the number of neutrons and the number of protons in the atom. The mass numbers of isotopes of carbon are shown in the table above. An isotope is often written with the element name followed by the mass number. Using this method, the isotopes of carbon are written as carbon-12, carbon-13, and carbon-14. Average atomic mass. You might have noticed on the periodic table does not list mass numbers or numbers of neutrons. This is because each element can have several isotopes. However, you might notice that a decimal number is listed with most elements. This decimal number is the average atomic mass of the element. The average atomic mass of an element is the average mass of the element's isotope, weighted according to the abundance. Okay, so this is kind of a complicated idea. The idea is that essentially we've got these different masses, right? 12, 13, and 14. We kind of average them out, but we average them out based on how common they are. Okay? So how do we do that? Okay, this is the process over here on the right-hand side. You can calculate the average if you know the percentage of isotope in the element. Okay, so lithium contains 7.5% lithium-6 and 92.5% lithium-7. What is the average atomic mass of lithium? Okay, you're going to change each percent to a decimal. To do that, you take the percentage and divide by 100. So that's shown here. So 7.5 divided by 100. Okay, and then we take 92.5, the percent of lithium-7, and divide it by 100. And then multiply the mass of the isotope by the percent. So 6 times 0.075 gives us 0.45. And then 7 times 0.925 gives us 6.475. And then you add those 2 numbers together. Okay, so we divide by 100 the percents. Then we multiply those decimals by the mass that they're associated with. So 7.5% was associated with lithium-6. So we take 6 times 0.075, and then 7 times 0.925. And then we take those two numbers and add them together. Okay, so you guys are going to follow that same process for nitrogen. So you would take 99.63 and divide by 100. And then you would take 0.37 and divide it by 100. Okay, then you are going to take the decimal that you got, and multiply it by 14, and take the second decimal that you got and multiply it by 15. Once you've done that, add the two numbers together, and that will give you the average atomic mass of nitrogen. Okay, so you're following these steps up here, A, B, and C, but you're using the numbers that are down here in number 5. Okay, so just replace 99.63, plug that in up here where the 7.5 was. Plug in 0.37 up here for 92.5, and then plug in 14 for 6 and 15 for 7. Okay, the values that you get, you're going to add together, and that will give you the average. Okay, not super important, but just something fun to try. Okay, next up, identify. What properties of carbon were averaged to arrive at the 12.01 average atomic mass? Average atomic mass. The figure on the left shows the block of carbon from the periodic table. It shows the average atomic mass of carbon is 12.01. The table on the previous page shows that carbon has 3 isotopes. Why isn't the average 13? Okay, because we have carbon 12, carbon 13, carbon 14. Well, it's not 13 because the average is based on the isotope's abundance. Since almost 99% of Earth's carbon is carbon 12, the average atomic mass is pretty close to 12. All right, moving along to talk about radioactivity. Okay, radioactivity. Okay, more than 1,000 years ago, people tried to change lead into gold by performing chemical reactions. However, they did not succeed. Why not? Today, scientists know that a chemical reaction does not change the number of protons in an atom's nucleus. Okay? All a chemical reaction does is rearrange the atoms and kind of what atoms are connected to each other. Okay? If the number of protons does not change, the element doesn't change. But in the late 1800s, scientists discovered that some elements change into others spontaneously. How does this happen? Spontaneously means occurring without any external force. An accidental discovery. Okay, in 1896, a scientist named Henri Becquerel studied minerals containing uranium. When these minerals were exposed to sunlight, they gave off a type of energy that could pass through paper. If Becquerel covered the photographic plate with black paper, this film would pass through the paper and expose the film. Okay? Essentially, that meant that it was acting like an X-ray. So think about how X-rays work, and when you get an X-ray, right, it produces an image of like your teeth or your bones. Okay, so how does that happen? Well, an X-ray passes through kind of your body, okay, and it doesn't pass through hard substances like your bone. So that leaves a white image, okay, kind of where the X-rays can't travel. Okay, well, that's exactly what he was seeing, except for there were no X-rays. Okay, so what was causing this exposure? Okay, well, what was causing the exposure was something that was released from uranium. So an image of the mineral appeared on the plate. One day, Becquerel left the mineral in a drawer next to a wrapped, unexposed plate. Later, he unwrapped the plate and found it contained an image of the mineral. The mineral spontaneously emitted energy, even in the dark. What was the energy? Okay, so what was being emitted by that uranium? Okay, it was a form of energy called radiation. Okay, Becquerel discovered, along with Pierre and Marie Curie, and Marie Curie called the elements that spontaneously emit radiation, she called those radioactive elements. Becquerel and the Curies discovered that radiation released by uranium was made of energy and particles. This radiation came from the nuclei of the uranium atoms. When this happens, the number of protons in one atom of uranium changes. Okay, when uranium releases radiation, it changes into a different element. So essentially what's happening is uranium, its nucleus is actually splitting up. So it's dividing the atom. Okay? And that is something that only happens in nuclear reactions, okay? Not chemical reactions. Okay, so types of decay. Elements, let's come back to this. Why can't scientists change lead into gold through a chemical reaction? Well, a chemical reaction will not change the number of protons in an element. Okay, so the only way to change lead into gold would be to change the number of protons in the lead atom to the number of protons that were in the gold. Okay, and that is not possible through chemical reactions. Chemical reactions only change the arrangement of the atoms. Okay, it doesn't actually divide or split atoms into new ones. Okay, so atoms cannot change from one type of atom into another through a chemical reaction. Okay, the types of decay. Elements that are radioactive contain unstable nuclei. Okay, a nuclear decay is the process that occurs when an unstable nucleus. So some elements are just naturally, their nucleus is unstable. Okay, it will change into another more stable nucleus by emitting radiation. Okay, sometimes this happens really fast. So an element will go from unstable to stable very quickly. Other times it occurs very slowly. So over millions of years. Okay, so nuclear decay can produce 3 different types of radiation: alpha particles, beta particles, and gamma rays. They're shown in the picture below. Alpha and beta decay change one element into another. Okay, previously we've talked about alpha particles. Alpha particles were what were shot at the gold foil that helped us figure out that there was a nucleus. Okay, so now we're kind of figuring out what those alpha particles were. Okay, so what happens? Okay, in alpha decay, we have an unstable nucleus, and that unstable nucleus is going to be divided. Okay, and when it's divided, okay, we are splitting off from this nucleus an alpha particle. Alpha particles consist of 2 protons and 2 neutrons. Okay, in beta decay, we also have an unstable nucleus. Okay, when it splits, it releases what's called a beta particle. A beta particle has 1 fewer neutron and 1, so it releases a neutron, okay, but it adds a proton. Okay, we end up with a beta particle being released, okay, and we're adding a proton to our atom. Okay, and then we've got gamma decay. In gamma decay, the nucleus is unstable, but the number of protons and neutrons won't change. Gamma rays are just being emitted by the nucleus. Okay, so question number 8. What does an atomic nucleus give off during nuclear decay? It's going to give off some form of radiation. Okay, explain the change in atomic number for each type of decay. Okay, in alpha decay, okay, the atomic number is going to decrease by 2, okay, because there are 2 fewer protons in the atom, okay, after the split. In beta decay, there's 1 more proton, so we add a proton to the atom, so its atomic number will increase. And then gamma decay, no change in protons, so the atomic number will remain the same or will not be changed. Okay, so you should be able to answer question number 9. Okay, alpha decay, beta decay, gamma decay. Hey, again, this is just going to go through and describe what we talked about up here in terms of the picture, so I'm going to skip past that. Hey, what happens during radioactive decay? The energy released by radioactive decay, hey, that's what's happening, right? So what's happening is energy is being released in some form, the nucleus goes from being unstable to more stable in the process. Okay, so what happens during the process of nuclear decay? An unstable atomic nucleus changes into another, more stable nucleus by emitting radiation. All right. Why do people who work with radioactive materials wear protective clothing? Okay, uses of radioactive isotopes. The energy released by radioactive decay can be harmful as well as beneficial to humans. Too much radiation can damage or destroy living cells, making them unable to function properly. Okay, that's why if you're working with radioactive material, we now know that we need to wear special protective clothing so that our cells don't become damaged or destroyed. Okay, being exposed to radiation can actually cause certain types of cancer. Okay, some organisms contain cells such as cancer cells that are harmful. Radiation therapy can be beneficial to humans by destroying these harmful cells. So if an individual has cancer and they have a tumor, okay, that means that there's a large number of cancer cells in one location. We can shoot radiation at that tumor, and that radiation will then destroy, right? We shoot so much radiation that it actually destroys those cells. Hey, we can't use radiation treatment for all cancers because some cancers don't produce large tumors in one area. Instead, the cancer cells are spread throughout potentially an organ, like maybe a pancreas. And then if we shot radiation at at all of the locations the cancer cells were, we would essentially be destroying the entire pancreas. Okay, so radiation therapy works for some types of cancers, but not all. All right, differentiate. How is an ion different from a neutral atom? Ions involve gaining or losing electrons. So what happens to a neutral atom if it gains or loses electrons? Recall that a neutral atom has no overall charge. This is because it contains equal numbers of positively charged protons and negatively charged electrons. When electrons are added to or removed from an atom, that atom becomes an ion. Okay? So when electrons are added to or removed from an atom, that atom becomes an ion. An ion is an atom that's no longer neutral because it has gained or lost electrons. So that's how it's different from a neutral atom. In a neutral atom, there are equal numbers of protons and electrons, whereas in an ion, there are either more electrons than protons or fewer electrons than protons. Okay, so it's no longer neutral because it has either gained or lost electrons. Positive ions. Okay, when a neutral atom loses one or more electrons, it has more protons than electrons. As a result, it has a positive charge. Okay, we'll talk more about this next week. I'm going to skip down here to the picture. Okay, this shows sodium and the protons and electrons, right? They pair up. They're equal in number for a sodium atom. Okay, if sodium were to lose an electron, okay, the number of protons and electrons is no longer equal. Okay, it has one less electron. That makes there one more positively charged proton. That makes a positive sodium ion. Okay, in fluorine, a fluorine atom has equal numbers of protons and electrons. Okay, if fluorine were to gain an electron, get one more electron, okay, instead of having a balance between protons and electrons, there's one more electron, and that means that fluorine has a -1 charge. Okay, why does fluorine have a negative charge? It has a negative charge because it has more electrons than protons, and electrons are negatively charged, protons are positively charged. How does a neutral atom change when its number of protons electrons and neutrons changes. Okay, so a neutral atom. Okay, if the number of protons changes, that's going to change the element to a different element or a different atom. Okay, a neutral atom, if we add or lose electrons, that will take the neutral atom and form an ion that has either gained or lost electrons. And then a neutral atom, okay, where neutrons change. So you take the atom, okay, like let's say it's carbon, okay, and we change the number of neutrons in the carbon, we are going to get different isotopes of carbon. Okay, so changing neutrons forms isotopes, changing the number of electrons forms ions, changing the number of protons changes the actual element or the atomic number or the type of atom. Okay, after you read, review the terms and their definitions in the mini glossary. Atomic number, number of protons in the atom of an element. Average atomic mass, the average mass of the element's isotopes weighted according to their abundance. Ion, an atom that's no longer neutral because it's gained or lost electrons. Isotope, atoms of the same element that have different numbers of neutrons. Mass number, number of protons and neutrons. Nuclear decay, process that occurs when an unstable nucleus changes into a more stable nucleus by emitting radiation. And then radioactive, spontaneously emitting radiation. Write a sentence that explains how to determine the number of neutrons in an isotope if it has 6 protons and a mass number of 13. Okay, so you're going to write a sentence that explains it. I'm going to come back up and show you that is related to the equation that we saw way up here at the beginning. Okay, we saw it, where was it at? We talked about atomic number, okay, number of neutrons, isotope, and right here, this equation, mass number equals number of protons plus number of neutrons. So you're using that equation, plugging in the information in this question, okay, and writing it out in a sentence, how you would find the number of neutrons. Write the symbol or expression that represents each particle. Okay, so you're going to use the information that's in some of the tables and some of the pictures, okay, that you have seen, okay, in the reading. And then last, if you could look inside an atom, what would you see? And what are the particles that are inside the atom and where would you find them? All right, ladies and gentlemen, don't forget to go back to the very beginning, okay, and go through and reread each of these statements. Okay, tell us if you agree or disagree now after we have read the chapter. I hope that helps, and have a great day. Bye.